display and metadata management SW for Snowcasting Heritage Project, the Church of the Nativity of
in Bethlehem.
In Bethlehem. Oh, excellent. Monsieur Bussoïc est président de SCDS et is the main coordinator of the planning and defining product strategy by identifying customer needs, markets requirements, competitive trends, and overseeing all aspects of business.
Okay. Hello, everyone. Thank you for coming to this presentation. I will start sharply. I will briefly introduce us, our company profile. Then I will go straight into showing you the Church of the Nativity project. I am here in front of you from, I'm coming like from two perspectives, different perspectives. I am one of the main contributors to this project, and I am also presenting our data management and data configuration management tool, which was extensively used during this project. I worked for developing this tool as a system architect. After introducing the project, I will show you a brief short video clip, few minutes, actually showing you the digital museum of Nativity, which we built after the project. It's actually the whole range of deliverables that have been produced in this project, so it's the deliverables gallery. And then I'll pass through our data management tool called Metadata X, showing you the main features. It's very visual. I have short videos for every feature, every important feature. We are speaking about storing the data, ways of storing the data, and managing the versions during the project life cycle. Then showing how exactly we use this tool in an international project involving about 7 different countries in North America, Europe, and Middle East. What are the upcoming implementations and the main contributors of this work? So SCDS Pro was founded in 2002, is based in Montreal, and actually gathers operational capabilities in Europe and different Middle East countries like Kingdom of Saudi Arabia, Kingdom of Bahrain, and United Arab Emirates. Our core business is 3D imaging, actually including data collection via HDS, laser scanning, and data processing and modeling. We are also very active in application development. We develop dedicated applications in industrial imaging, data management, software design, and integration. I will also speak briefly about EasyBeam, these concepts which are aligned here, EasyBeam, Easy Aim, and Engineering Audit, when I will introduce Metadata X, because it's Metadata X actually is directly related to EasyBeam. Data mining, numerical analysis, capacity building, and distance learning. So, this project, the Church of the Nativity project, dealt with in phase 1, where we participated actively with the structural analysis for roof restoration, intervention proposals, diagnosis, methodologies, design, elaboration of guidelines and recommendation. Our company was part of an international consortium which was set up to perform this project for survey, study, assessment, and conservation plan for the Church of the Nativity in Bethlehem. We take a few minutes just to look into this, how we show here how data collection was done actually, and how data have been processed and modeled in order to come up with the deliverables and arrange them, store them in the digital museum. It's, as I said, just a few minutes. This digital museum was entirely built with information and data we collected on the site, or information and data we processed during the modeling phase. You can see all kind of deliverables at CAD level, from as-built drawings up to deformation analysis drawings, deformation curves and surfaces, structural analysis models. Pretty advanced set of package of deliverables. 3D models, too, that have been used for creating the viewers in the data management tool. You see the world deformations and all this stuff, partly 2D, partially 3D. We also dealt with the different levels of spatial informations from the grottos, the underground tunnels, called grottos, passing by the basilic, the main basilic of the Nativity, up to the roof. So we installed our equipment and sensors all over this site around, in order to generate what you see here. So this is the general plan. Actually, it's the road of the general plan of all layouts, different, from grottos up to the roof. As I said, we made use of metadata X, which is what exactly? Firstly, a configuration management tool, data configuration management tool. It's a graphical management tool for any kind of data, and you'll see why it's graphical, very visual. So the archives we use are quite visual and very user-friendly. It's an effective way of packaging and presenting a project deliverables. It's easily deployable through our viewers, which you'll see shortly. The same, it's an environment implementing, it's an analysis environment to implementing specific toolboxes for data mining, for conditioning, for evaluation and analysis. And I also put here, it makes the transition, it creates the transition from easy BIM to easy AIM. BIM, we are speaking about, firstly, first principle, this tool, this package, this software package, can be used in any type of project, regardless. I didn't see so far any type of project that cannot be used for and integrated within our data management environment. And like we said, it makes the passage from BIM, building information modeling, is what exactly, briefly? It's a kind of process dealing with creating, collecting data information, spatial information, and processing it. It's exactly what we are doing, but we make the transition from simple BIM to easy AIM, which we call not building information modeling, but any entity information modeling, whether it's a plant, site, municipality project, or whatever. It's open source, user customizable to a large extent, and of course it's SQL compliant. Now, I want to rush up a bit and skip the flowchart, because the flowchart just shows the main capabilities which you'll follow here. So it's integrated, for example, with customized Google features. These are within the customization is done within the tool. What you saw there before, it's exactly the configuration of all the projects we have around the world. Once you click on one of them, you get inside the project entirely. It runs on both intranet, so there are two actually versions. It's intranet and internet version, and we also release the combined intranet and internet. Like at the enterprise level, a project which is performed in an enterprise can involve stakeholders from both the organization and outside. This is why we came up with the combined range, intranet and internet. The first way of putting the information is within like a normal architecture, which is actually file and folders concept. All the data, you see it's structured like this, and can be, of course, accessed either 2D or 3D or meta, can be accessed directly from the metadata file list, storing and showing all the files that are used in the project. We have here kind of documents, CAD files, point clouds, scan data, ASCII, binary, whatever. So any type of information actually goes here. Viewers, we were speaking about graphical storage and storing the data graphically, actually. Here we present the 2D viewers. So a 2D viewer is either a CAD drawing or a drawing, you see, or an image, a picture. Any type of 2D representation can become a viewer in seconds. Once prepared, you see, here we were showing the CAD viewers, like the viewer embedding all the CAD files inside, in different locations corresponding to or associated to their role. The same for, we said CAD now. It's still CAD, but at the Grottos level, at another level. So, for example, in a building, we can have viewers per floors, viewers per rooms. All of them arranged in an hierarchical mode. The links between these viewers, how these viewers are, how the architecture of these viewers is established is according to the entity configuration, to the building, to the site, to whatever this is. Photos view are the same, like photographs, thousands of photographs. And we came up with another viewer which is not shown here. It's what we call iconless viewer. This is icon active viewer, where all the icons are shown and active. Of course, the disadvantage is these icons will mask a lot from the viewer itself. So we came up with an iconless viewer where no icon is shown, but once you hover on with the mouse, you get immediately the information in that particular area in terms of name of the file and type of category of information. 3D, the same. These are like Leica true views, for example, inserted also into the viewers, and others like videos. Okay, now I will introduce a different type of viewer, which is unique in tools like this, which you call cycloramic viewers. So kind of, I would say, spherical panorama viewers, if you want, where in order to create a viewer like this, you just have to create the spherical panorama file, and then it's imported inside the tool immediately. Here, what we show how we put a file into a viewer, how we store a file into a viewer like this. We just have to open up the viewer. You see, of course, we put a description, which is file metadata or information, or however you want to call it, and then we open up the viewer, and just by selecting a point, for example, I can put I want to put this file in this position when I click the mouse, or in that position. If you see, all the coordinates here at the bottom changes when I click the mouse. The coordinates change because the position changed. So finally, I decided I will put the file in this particular position. These particular coordinates are, of course, automatically stored after the click, after activating the click on the viewer. And this is the new file that has been put there. Now we are going to the viewer itself and opening the viewer. With the information. You can see there are documents, there is spatial data, there are photographs, 3D. This is the file we just inserted in that particular position, if you remember. Yeah. So it's actually a video recording of the same site, Church of Nativity, the Catholic Quarter. Okay, just let it finishing a bit to see how it comes with the next there. So actually, as I said, in order to generate a viewer like this, normally it takes about I would say minutes, 5 minutes to collect the information, 5 minutes to collect the information, and about half an hour to process the information. To enter the viewer, this is done in seconds, But we get a very visual environment where we can store and manage the data we work with. Okay. True views are also integrated shortly. True view is I don't know if you are familiar with Leica's TrueView, but these are kind of same virtual environment where we can do even more in terms of we can annotate, we can perform simple measurements and all this stuff. Sometimes the requirement, some clients love TrueViews, so we also integrated TrueViews with this. The same, we have a specific icon for TrueView. Click on it, and then the TrueView is simply open, and go inside, get to the data we need, whatever we want to do with this. Configuration management, check-in, check-out. So we implemented a very simple and effective mechanism for data configuration management. Basically, check-in, check-out, and versioning of any type of file. Like we see here, we have access by checking out. We have access to any previous version. No modifications. Then checking back in. We have access to meta information like username, time of modification, whoever did this, and what is also very important, the revision history. as I said, we used for this project, for the first time, we used a combined like intranet internet deployment. The server, the metadata X server, was located in Montreal, communicating with all these project stakeholders from all these countries. So the application was installed only here in Montreal. The others accessing it, different time zones, doesn't matter, using normal machines, normal workstation, portable, whatever. So this was how it worked. Actually, was the first very successful implementation model of using metadata X in an international project. These are upcoming implementations, so we advanced a lot with the anaglyphic cyclorama viewer. We are working on a 3D object viewer, security level upgrades, other analysis tools like cladding design and monitoring toolboxes. These are the main contributors. Daniel Chudak is one of the real pioneers of the laser scanning. He was working for a company that was precursor of Leica Geosystems. Yeah, this project actually, plans from this project have been awarded by Leica Geosystems, second place in the world in that category, heritage buildings. Thank you very much for your attention.
Avez-vous des questions? No question?